Hey, welcome back to part 3 of sniffing reverse engineering and coding an ESP32 Bluetooth application. I didn't get really any feedback from the last video, but how can I expect to? There's very few people watching the videos so far. So what I decided to do is, this is part 3, it's going to be the last part of this video series. And the first part I'm going to go back and kind of cover what we did in part 2, just to remind you about the UUIDs and how those work. Then we're actually going to write an application on the ESP32 that talks to the Lumin Plus that we purchased from 5 and Below, and then we sniffed and make it cycle through some colors. Once you have that basic code, you can pretty much go off and make it do anything that you want. If you want to use it to notify you when you get emails, or maybe tie it into if this, then that. Whatever it is you decide to do, you'll have the ability to go off and do that. So with that, let's actually go to the computer now and get started.
Let's go ahead and take a look at the information from the sniffing that we did in the last episode. If you remember, we used the NRF52480, we used Wireshark, we installed some software in part 1, and using the Happy Lighting application on a smart device, we sent commands to it to change colors, to turn off, turn on. We capture that information. We then looked at the packet information for the Bluetooth communication, and we reverse engineered it, figuring out how to both turn it on and off and how to change the colors. The key things that we learned were we learned about service UUIDs, we learned about characteristic UUIDs, and we learned about the actual address, the service address of the Bluetooth device. Now, something to keep in mind is that whenever you have one Lumin Plus, it will, and you've got it turned on, it will broadcast this address right here. If you have two, the second one will see that the address is used and generate another address. So the code I'm going to show you that I wrote does talk directly to the server. But I'm first going to show you some code in the ESP32 BLE client example and explain how that works, so that if you decided to, you could control a whole host of Lumin Plus devices. So with that, let's go take a look at the example code. Okay. I'm using the Arduino IDE. You can use that as well. It's what I recommend for at least starting out. There are some excellent other resources like Platform IO and Visual Studio that I typically use for larger projects. But Arduino is simple, it's easy, people can get a hold of it, it's easy to set up. There are probably plenty of videos on YouTube on how to install the ESP32 board onto the Arduino IDE. I'm going to leave that up to you to do. However, once you get it installed, if you go under the examples and look for BLE, ESP32 BLE Arduino, and look at the client, this is the code that we're looking for. Now, what's important in this example and what I want you to understand is a lot of times you don't talk to the servers directly. You don't use the server ID like I'm going to. Instead, what you do is you look at the broadcasts that are coming in from all Bluetooth devices and try to identify the service ID that you actually want. That's what this code does. So if you look here, it's looking for this service ID, whatever this happens to be. It might be, part of a two-part example, maybe a client and a server example. And then you have this characteristic ID. So what's really interesting to see here is if we go down to the loop, and reminding you that the loop is called multiple times. It's called, over and over again. And it's looking to connect. It's wanting to know, have we connected or not, true or false? So let's go to the setup. Remember, setup gets called once. What's interesting is we are initializing the Bluetooth on the ESP32, and we're setting up a scan. The scan is going to be for 5 seconds. And every time we get an advertised device telling us it's available, it's going to call, actually it's going to create and call this class, and this class has an on result. So what am I saying? I'm saying that compiling this code, putting it on the ESP32, will cause it to initialize the ESP's Bluetooth device and start listening for 5 seconds for all advertised devices within range. And every time it hears an advertised device, remember that's how Bluetooth works. The Bluetooth server, if you will, actually broadcasts that it's available. Then the clients actually see that broadcast and connect to it. So in this case, basically what it's going to do is every time it hears an advertised device, it's going to check, does it have a service, and does it match the service ID we're looking for? If it does, then we're going to connect, and that will continue the rest of the app. Now, I really want to point this out to you, that going back to the concept of Bluetooth and services, it is important to understand that maybe you're not looking for a specific device, you're looking for a specific service. For example, this is the classic example. You're looking for heartbeat monitoring. What is the person's current beats per minute? Well, that can be provided by a lot of different devices. And if you go to the Bluetooth.com website, you can even look up what the generic service name might be for that. So you could put that service ID in here, and maybe your Fitbit would respond to that. Maybe a device next to a hospital bed would respond to that. So the idea isn't focused on the actual device that is providing the service, it's focused on the service itself. And that's the standardization that they're trying to do. Now, our Lumin Plus does not do that. It's kind of, it's a cheap device. It has not registered any services with Bluetooth.com, that whole consortium. It basically just works with its app, and we sniffed in on that app. So what I want to show you is the app that I wrote. Okay, so this is the RGB randomizer that I wrote. It's really simple. It'll show you how to connect to the Lumin Plus if you decide you want to play around with it. We have the server UUID here. It seems to be consistent across all devices unless you have more than one of them in the same broadcast range. So if you have one, this is how you can do it. We have the service UUID that we sniffed and the characteristic UUID that we sniffed when we changed the colors. Here we're going to create a client, a Bluetooth client object. It's a pointer to one. We're going to set up the address, a Bluetooth address to the server. And we're going to set up a remote characteristic, a pointer to one, and a pointer to a service. Service and characteristic. We got this data. This is called RGB color data. And if you remember right, RGB are these zeros that were in here. If we were to go back and look at the sniffing data, when we sent colors, we looked at an R, a G, and a B from the application. We sniffed it, and we were able to determine that these 3 bytes in the data represented the color. The first thing we do is we initialize Bluetooth on the ESP32, and then within a loop we check if we're connected or not. If we're not connected, which is the default state, we connect. If we're successful at connecting, then we set connected equal to true, and we get the service. So we set our pointer to the remote service and the remote characteristic. That's what we need to actually kind of talk to the device. Now what we do is we just check if we're connected. We just make sure it's not a null value. And you can put better code check, error checking and stuff in here, but we're going to make sure it's not null. We're going to make sure that we can actually write without a response. If you remember right, when we sent the data, there's write with response, write without response, notify. There's a number of different Bluetooth characteristic types. In this case, we just send it and hope it works. And that's how the device was set up. We generate a random number, which in this case isn't seeded. If you want to seed it, go right ahead. Seeding of randomness just causes it to be truly random. If you start this each time, you'll get the same colors. We then fill the array in the positions we need to with the RGB data. We then call remote characteristic to write the data to the Bluetooth device, and we then pause for 500 milliseconds, half a second, and then we go back and do it again. That's pretty much all there is to it. And doing that, as you saw in the intro, we're able to cycle through multiple colors. So in part 2, I kind of mentioned, hey, maybe I'll do like a heat map or something, but there was really no feedback. So I decided to get the video out to you so that at least you could go off and create different solutions and maybe share them with us. That would be really awesome. I appreciate you watching the videos. This code will be available. I'll include a link to it. It'll be on Bitbucket. And if you feel like it, please subscribe or offer comments. I'm open to suggestions. I have a number of other projects that I'm going to do and hopefully continue to create videos of those projects. So anyway, thank you for watching and take care.